Okay, I think we can get going because it's coming the last part of the day and everyone's getting tired. Ivan is going to take us to the implementation of autonomous transactions journey. And yeah, we can get started. Thank you.
Hello, you may call me Ivan.
Closer.
Hello, you may call me Ivan Kush. I'm from Tantor Labs. We develop database that is based on Postgres. So in this talk, I'm going to tell you about one of the possible implementations of autonomous transactions. So autonomous transaction is a transaction that may be committed even if the main transaction is rolled back. They are not in SQL standard, but many databases use them with their own syntax. In this example, common use case is to declare a block of SQL statements with some attribute. On this example, we declare the function with pragma autonomous transaction. That means that this function will be executed in the different session. Let's analyze the example. In the main transaction, we execute begin. It does start the transaction. Then we insert the value 0 to the table. Then call the function for. It inserts value 1 to the table. And then execute rollback. So our main function should roll back. And when we select from the table, we see that value 1 is in the table and value 0 not in the table. So value 1 was stored, although the main transaction is rolled back. So common use cases are logging, auditing, integration with some external IP, debugging. Also many databases use them. So when we try to convert code from other database to Postgres, we could use such construction. Also, non-transaction commands may be executed in autonomous functions like vacuum and many other, create table, etc. So a bit of glossary. Main session is the session through which user interacts with the server. Main transaction is a transaction in this session. Autonomous session is an independent session that is created from main session. And autonomous transaction is AT, autonomous function that will be executed in the autonomous session. So autonomous transaction characteristics. So this is independent transaction that don't depend on the state of the main transaction if the isolation level is serializable. Also, autonomous transactions can launch another transactions. And this is a high-performance alternative to extensions like dblink and PG background. So here examples how used of the syntax of autonomous transactions in different databases. 3 below are Postgres-like databases. They have 2 types of syntax. Maybe we have another databases, but I don't know about them. I mean about Postgres. So we skip some slides because we have low time. Here examples how I used in different databases. So we don't have autonomous transaction in Postgres, but we have extensions that have such functionality, like dblink, PG background. Also, we can use PL Python for such behavior. But they all have some disadvantages. Performance and security. For example, PG background uses background workers, and for each function execution, we create and destroy background worker. And dblink has security problem that passwords are stored in plain text. No bell button and skip. So a bit of history. First nodes of when we try to realize autonomous transactions, many questions arise like security, implementation, semantics, replication, and many other things. We need all solve it. That's because I think autonomous transactions aren't in the Postgres at the current time. So those discussions in hackers were from 2008 till 2011. They discussed the concept and semantics of autonomous transactions, but no patches were introduced. In 2014, Rajiv Rastogi, a guy from Huawei, have introduced the first patch with implementation. He have used PGPro data structure for storing autonomous context and return to the main context. So we have only one process that implement main transaction and autonomous transaction. Okay. In 2016, Peter Eisentraut also introduces a patch. At the time, Postgres have had background workers, and so Peter used them to implement autonomous transactions. So I think I skip this a bit. So he has some advantages and disadvantages, and based on Peter's patch, we implemented our patch that has some common internal characteristics. So we don't have Python at the current time support, but we have PG SQL support using Pragma autonomous transaction. We implemented using background workers, synchronous execution. For communication used Postgres client server protocol. Messages are sent through dynamic shared memory. Infinite nested calls of autonomous transactions are possible. So we have pool of autonomous sessions for which backend. More statements are supported than in Peter's patch, and many tests. So here's the link if you like to read. So let's see an example. Here's an anonymous function. Here is a Pragma autonomous transaction, and in the function we have transaction management commands like start transaction, comment, and rollback. By default functions, we can't use transaction commands. So the advantages of the patch that we have pool of sessions, no need each time to create and destroy background workers when we execute an autonomous function. Also, many statements are supported. Almost no need to refactor as current Postgres code. We use the generally accepted Pragma autonomous transaction, and it works. Some disadvantages. It uses background workers, so we need many systems Postgres use them. So we need somehow to split background workers that are used in autonomous transaction from other using, because we could use many times transaction and the background workers will be exhausted. So the next step is need a common pool of autonomous transactions for all backend. No, this is for security, rule system. It's better to have. Also, from Peter's patch, 7 years has passed, and community now doubts, do we need them in the core Postgres? And how we need to implement them more generously. Maybe we don't need them in the Postgres, and somehow with different mechanism could implement the needed functionality. So now about internals of implementation. Dynamic shared memory segment is allocated at first. Then table or shared memory table of contents is created. Table of contents is a dictionary whose values links to addresses of other entities in the rest of the DSM. So, and then the entities itself allocated. We have 4 entities: user data. They contain some authentication information. Then we have 2 shared memory message queues through which communication between main session and autonomous session will be. And then the settings of the main session that are used in the autonomous session. So we have such segment, then we launch a background worker, past the handler function to it. Background worker is created, begins to execute handler. Handler reads all this data and internalises structures for autonomous session. Then send the message to the main session that it's ready to execute commands, and the infinite loop begins. So let's see example this. So we have a function with pragma autonomous. It will be executed in autonomous session. So autonomous session was created, and main session we have. So we have a command execute and sort into table values. It's parsed by main session. Insert command is extracted. This command is sent. This command is sent to the autonomous session. It was executed there, and then back the command zit. That means complete, and main session continues its execution. So we have a pool for which backend it's created lazily. We have destroying of sessions by timeout. We needed to clear memory because caches occupy it. And no, this is not beautiful, but simple solution at the current time. After execution, autonomous session is returned to the pool. At the current time, tell the truth, only one session is sufficient, and we have synchronous execution between main and autonomous sessions. But as some statements not supported, sometimes we need more autonomous sessions. So let's see examples. We have a table with integrity constraint. All our values should be greater than 500. We have autonomous function with 2 inserts. They executed in 2 transactions. At first, we insert 700 and then 100. It violates constraint, so the transaction is rolled back. And table contains 700 only. The second example is all these inserts are in transaction block. They are executed in 1 autonomous transaction, so we also insert 820, 20 violates the constraint, so all transaction is rolled back and our table is empty. So it's possible to execute non-transactional commands like vacuum and many other, alter system, and so many other. Exception handling is possible. We have here 2 races, 1 notice and 1 exception. Exception was cached from other function. And so when we execute this function, we have 1 notice, and we have notice about exception that was cached here. At the current time, we have, it's possible to use transaction management commands in procedures, but they have not very beautiful, we may say it. So let's analyze the procedure P2. At first it inserts 100, then commit command, and then 800 rollback command. After first commit, our main session, our one transaction is completed and automatically was started the second transaction that was rolled back. So we have in the table only 700. But it's impossible to call a procedure that manages transactions from a simple functions. We have an error. Here is a function that calls our previous procedure, and we got an error. So it's impossible to execute also non-transactional commands in the procedure. We call here vacuum, and it's impossible to execute. We have an error. Also, Also procedures don't return values. So it's a disadvantage because we can't use in some operations. Also, we have a different syntax to call procedures and functions. We have some time to rewrite them. So some benchmarks. We have a double link implementation with PG background implementation. Also, we have Pragma autonomous transaction with pool of workers, and Pragma Peter means without pool of workers. As we can see, with more connections, we have more TPS using pool. So pool is a cool thing. So here's a code for benchmark. I think it's not interesting for now. And the third plans, we try to implement remaining statements in PGSQL. Also, Python support, common pool for all backends, asynchronous or autonomous transactions. And of course, we try to solve all questions from